Hello everyone, welcome to ACE Maths. In this video, we are going to learn how to rationalize the denominator when working with surds. We will also be solving many example questions so that you can understand the concepts very well. So what does rationalizing the denominator mean? It simply means removing the roots from the denominator. Let's take an example. Let's say we have 1 over root 3. Here the denominator is root 3, that is a surd. So when the denominator of a fraction contains a surd, we rewrite the fraction so that the denominator contains only rational numbers. This does not change the value of the fraction. We are only rewriting it in a more acceptable form. So 1 over root 3 is actually equal to root 3 over 3. Now look at this new denominator, that is 3, and it is no longer a surd. So think of it like simplifying a fraction. A fraction is not considered fully simplified if the denominator contains a surd. Here 1 over root 3 is equal to root 3 over 3. I have successfully removed the surd from the denominator, and that is why this new fraction root 3 over 3 has a rational denominator. So okay, now let's talk about how do we rationalize the denominator. To rationalize the denominator, we multiply the top and the bottom, that is the numerator and the denominator of the fraction, by a suitable surd. So let's see what we mean by that. In the previous slide, we had 1 over root 3, right? So let's say I want to rationalize the denominator of this fraction. So what if I multiply this fraction by root 3 over root 3? Here I have multiplied the top with root 3 and the bottom with root 3 as well. So 1 multiplied by root 3 is root 3 over root 3 times root 3 is actually 3. So now we have a fraction with a rational denominator. So this is the process of rationalizing the denominator of any fraction. Now let's understand a very important mathematical concept, that is multiplying a fraction by x over x does not change its value. Let's say we have a fraction 1 over 2, okay? And now if I multiply this fraction with 3 over 3, look carefully that this 3 over 3 is in the form of x over x. That means I am multiplying the top and the bottom with the same number. Now let's multiply this. We have 1 times 3 is 3 and 2 times 3 is 6. Now if you simplify this new fraction, that is 3 over 6, we will get 1 over 2 because 3 multiplied by 2 is 6. So we started with 1 over 2, and after the simplification we are left with 1 over 2. So the fraction did not change. That is why whenever we have a fraction, we can multiply the top and the bottom with the same number, and it will not change the fraction at all. Let's take And another example, let's say we have 1 over root 2, and let me multiply it with root 2 over root 2. So I am multiplying the numerator and the denominator with root 2. So it will give me root 2 over root 2 times root 2 is just 2. So we need to remember that this fraction 1 over root 2 is equal to root 2 over 2. We will use this simple property to rationalize the denominators. Now we will try to rationalize some denominators which contain a single surd. So the first question is 1 over root 10. Here the denominator contains only one surd, that is root 10. We can multiply this fraction with root 10 over root 10, right? So if I multiply root 10 in the numerator, it will be just root 10, and in the denominator, root 10 times root 10 is just 10. So here I have successfully removed all roots from the denominator. So we have the rationalized denominator. Moving on to the next question, we have 3 root 2 over root 6. Here again, the denominator contains a surd, that is root 6. So we multiply the top and the bottom with root 6. Alright, in the numerator we will have 3 root 2 multiplied by root 6, and in the denominator we will have root 6 times root 6, that is 6. Okay, now let's multiply in the numerator. So we will have 3, and I can multiply this under the same square root. So it will become 3 root 12 over 6. Root 12 is actually 2 root 3. So I can write it as 3 multiplied by 2 root 3 over 6. 3 times 2 is 6. 6 over 6 is 1. So finally we will have root 3. And root 3 can be written as root 3 over 1. So now we have successfully removed the surd from the denominator. So root 3 over 1 or root 3 would be our final answer. Now let's solve the next question. Here we have 4 over 3 root 3. Here also the denominator contains a surd, that is this root 3. So I will multiply the top and the bottom with root 3. Now let's multiply. 4 times root 3 is 4 root 3, and in the denominator we will have 3 multiplied by root 3 times root 3 is again 3. So we will have 4 root 3 divided by 3 times 3 is 9. So 4 root 3 over 9 would be our final answer. Now let's look at a more advanced case where the denominator has two terms. Here we have 3 examples, and if you look at the denominator of each fraction, you will find there are 2 terms. In the first example, we have 2 plus root 5. there are two terms here, 2 and root 5. In the second example, we have 3 minus root 7, that is the second term. And in the third example, we have 2 as the first term and root 3 as the second term. Now let's take the first example. We have 3 over 2 plus root 5. Let's try to rationalize the denominator using the rule that we have learned so far. So according to what we have learned, I should multiply this fraction with root 5, top and bottom, right? Because root 5 is the third part present here. So let me see what happens. So let's just multiply. 3 times root 5 is 3 root 5. And in the denominator, we will have root 5 multiplied by 2 plus root 5. If we simplify it, we will have 3 root 5 over 2 root 5 plus root 5 times root 5 is 5. I am just multiplying this root 5 with 2 and then with root 5. So, did we successfully rationalize the denominator? No, because here the denominator still contains a surd. That is why we cannot use this method to rationalize a two-term denominator. We, instead of following this method, will multiply the conjugate of the denominator. So let's now learn how to find the conjugate. So the conjugate is found by changing the sign between the two terms. So here we have 2 plus root 5 in the first example, right? So to find its conjugate, we need to change the sign between the terms. So this positive sign will be changed to a negative sign. So it will become 2 minus root 5. So 2 plus root 5 has 2 minus root 5 as its conjugate. Now let's talk about the second example. We have root 5 minus root 4. Again, we need to change this symbol. So we will have root 5. Instead of minus, I will write plus. So we will have root 5 plus root 4. And here in the third example, we have root 7 minus 2. Again, I will write the conjugate as root 7 plus 2. I change the sign that is present between the terms. So plus becomes negative and negative becomes positive. Okay, so now we know how we can find conjugates. So now we will be able to solve this particular question. Here we have a two-term denominator and we need to rationalize the denominator. So first look at the denominator. We have 2 plus root 5. Okay, so that is 2 plus root 5. So we need to multiply this fraction with its conjugate. The conjugate of 2 plus root 5 would be 2 minus root 5. So I will multiply this fraction with 2 minus root 5 over 2 minus root 5. So let's solve the numerator part and the denominator part separately. So in the numerator we have 3 multiplied by 2 minus root 5, right? We know how we can solve this. First we need to multiply this 3 with 2 and then we will multiply 3 with negative root 5. So 3 times 2 is 6. 6 minus 3 times root 5 is 3 root 5, right? So that is the numerator. Now let's solve the denominator. In the denominator, we have 2 plus root 5 multiplied by 2 minus root 5. This can be solved using this simple algebraic identity, that is a plus b multiplied by a minus b is a squared minus b squared. If we use this identity, we will be able to solve this question. So here we have 2 in place of a and root 5 in place of b. So a squared will be 2 squared and b squared would be root 5 squared. So 2 squared is 4 and root 5 squared is 5. 4 minus 5 is negative 1. Alright, so we have the numerator and we have the denominator. So 3 over 2 plus root 5 is actually 6 minus 3 root 5, because this is the numerator, right? Over minus 1, the denominator. This minus sign will be multiplied in the numerator and it will become minus 6 plus 3 root 5. So now we have successfully removed all the third portions of the denominator. Here the denominator is just 1, and this would be our final answer. Okay, now let's solve this next question. Here we also need to rationalize the denominator. Look closely, we have 3 minus root 7 as the denominator. So what will be its conjugate? 3 plus root 7, right? So we need to multiply with 3 plus root 7, top and bottom. So 3 plus root 7 over 3 plus root 7. Let's solve the numerator part first. We will have 4 plus root 2 multiplied by 3 plus root 7, right? Let's see how we can multiply this. First, I can take this 4 and multiply this 3 plus root 7 with it. So take 4 and multiply 3 plus root 7. Then we will have this plus root 2. So take plus root 2 and multiply this 3 plus root 7 with it. Now let's multiply inside the bracket 4 times 3 and 4 times root 7, root 2 times 3 and root 2 times root 7. So 4 times 3 is just 12 plus 4 times root 7 is 4 root 7. Root 2 times 3 is 3 root 2 and root 2 times root 7 is root 14, right? Now let's solve the denominator. We have 3 minus root 7 multiplied by 3 plus root 7. Again, using the property a minus b multiplied by a plus b is a squared minus b squared. I can write this as 3 squared minus root 7 squared. So we know that 3 squared is 9 and root 7 squared is 7. So 9 minus 7 is 2. So we have the numerator and the denominator. So let's see what would be the final fraction. So we have 4 plus root 2 over 3 minus root 7, and we have rationalized the denominator, and the new numerator is 12 plus 4 root 7 plus 3 root 2 and plus 14. Since these are not like terms, I cannot add them together. So this would be the numerator and the denominator is 2. Okay, so this is the new numerator and 2 is the new denominator, and this would be the final answer. So this is our next example and I want you to try it on your own. Please try to solve it carefully and comment your answer. Rationalizing the denominator is one of the most important Surd skills for IGCSE extended examination. In the next video, we will solve mixed exam questions using everything we have learned about Surds. Thank you for watching and I will see you in the next lesson.